In the name of Almighty Allah, Assalamu alaikum dear students, how are you? Again, your teacher Faisal Omar with you. Today we are going to study Lewis structure. Okay, let's see what is this. A Lewis structure is a combination of Lewis symbols that represents the formation of covalent bonds between atoms in a molecule. Let me tell you again. A Lewis structure is a combination of Lewis symbols. The combination of Lewis symbols that represents the formation of covalent bonds between atoms in a molecule. What is the Lewis symbol? First of all, we have to recognize this Lewis symbol. Then we will draw the Lewis structure of some molecules. Okay. We can represent the chemical bonds. We know that one bond is made up of two electrons. We can represent it with a line representation or electron dot representation. If it's with the electron dot representation, then it's a kind of Lewis structure. And in Lewis structure, we use the Lewis symbols. And it's line representation. We don't need to write the dot for the electron. Let me show you with the example. If we have fluorine, we know that the fluorine has 7 electrons in its outermost shell. If we want to write the Lewis symbol, right now I am writing the Lewis symbol for the fluorine. We know the symbol of fluorine is F. We know that there are 7 electrons outermost shell. 2 electrons is the first shell. We don't count the first shell when we write the Lewis symbol and Lewis structure. We write the valence shell. Valence shell is the shell that takes part in the reaction. So, fluorine has 7 electrons in valence shell. 1, 2, 3, 4, 5, 6, and 7 electrons. So right now it's fluorine. And if we want to write another fluorine, and if we want to complete a fluorine molecule, we can write something like this. 1 fluorine. 1, 2, 3, 4, 5, 6, 7, and over here, this is the bonding pair between the fluorine. If we write only one of them, it's Lewis symbol. And if we write both of them, in this case, it's the Lewis structure for the fluorine molecule. Okay, every electron is represented as a dot in writing the Lewis symbol. And when we mix two Lewis symbols to form a molecule, to form a compound, to show a compound, the chemical bonds, in this case, is known as Lewis structure. If you want to represent this one with a line representation, we can write something like this. Fluorine and fluorine, one line. This line shows one bond or 2 electrons. And if you want to write these electrons around each fluorine atom, we can draw something like this. Okay? Each one of them shows 2 electrons or a pair of electrons. These are known as lone pairs. These pairs are known as lone pairs, and this pair is known as bonding pair. Remember this, guys. One bonding pair or one lone pair is made up of 2 electrons. If the pair is between 2 atoms that are forming molecule, that is known as bonding pair. Over here, this one is these 2 electrons are bonding pairs. And these electrons around each fluorine atom are the lone pairs. Okay? Over here, this is the line representation, and this is the electron dot representation with the Lewis symbols. Okay, students, let's work upon some example and how can we write a Lewis symbol or draw a Lewis symbol. First of all, I am going to show you an example is boron trifluoride. I have written some steps over here. You can follow these steps to write the Lewis structure of a molecule. Remember this. First of all, count the total number of valence electrons. For boron, the valence electron of boron is 3. Boron has 2 electrons in the first shell, but 3 electrons in the next shell. So we count the next shell, boron. For boron, we have 3 electrons. For fluorine, we know that for fluorine, we have 7 electrons. And there are 3 fluorines, so 7 times 3 makes 21 electrons. Now we add them up. The total number of electrons are 21 plus 3, 24 electron. Okay, so we finished the first step. The next step, write draw a possible skeletal structure for boron trifluoride. When we look at boron trifluoride, we see that boron is one atom and fluorine has 3 atoms. So obviously we can consider that boron must be in the center and fluorine around the boron trifluoride. So we can write a possible structure like this: boron and 3 fluorine. Okay, so we have written a possible structure. Now we have to put bonding pair between each of them, which means that a pair of electrons or 2 electrons. Okay, let me put the electrons between them. To form a bond between fluorine and boron, there must be a pair of electrons. That's compulsory. Without a pair of electrons, they cannot make a bond, covalent bond. So one pair of electron between fluorine and boron over here, again one pair over here, again one pair. So totally we have 6 electrons. Okay, so what's the next one? Next step, we have written 6 electrons out of 24. How many remaining? 18. The next step is complete the octet of electronegative atom. Which one of them is electronegative one? Fluorine is the most electronegative element, we know that. But we have to compare the elements, the atoms that are taking part in the reaction. So when we compare boron with fluorine, fluorine is more electronegative. So we have to fill the octet of the fluorine. So we have 2 electrons, 3, 4, 5, 6, 7, 8. Okay? 2, 3, 4, 5, 6, 7, 8. How many electrons? 8, 8, 16. 17, 18. How many electrons left? 24 minus 18, 6 electrons. 1, 2, 3, 4, 5, 6. Now it's complete. We have the Lewis structure of boron trifluoride. But in case, if the electrons are still remaining, in this case, if the electron, we need more electrons to fill the bonding pair between these 2 atoms. In this case, we can form double bonds. We can borrow these electrons and we can put as a bonding pair inside them. Okay, so let's work up on another example. The next examples are sulfur trioxide and carbon dioxide, and then I will give you a homework, the activity: draw Lewis structure of sulfate ion and methane and HCl or hydrochloric acid. You have to draw this Lewis structure, and if you can do it. It means that you have learned today's lesson. Okay, so sulfur has 6 electrons, oxygen has 6 electrons. We have 3 oxygen, which means that 3 times 6, which makes 3 times 6, 18 electrons. Okay, if we add up these electrons, what are the total number? What will be the total number? The total number of electrons will be 18 plus 6, 24. Let's draw possible structure. We have 1 sulfur and 3 oxygen. So sulfur must be in the middle. 1 oxygen, 2 oxygen, and 3 oxygen. We have 24 electrons. I've told you that we must fill the bonding pairs between 2 atoms in the molecule. So we have to give 2 dots or 1 bonding pair between each of them. So totally we have 2, 2, 2, 6 electrons. How many remaining? 18 electrons are remaining. So if we put these 18 electrons, in this case, the most electronegative element of them is oxygen. So for oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now let's count the electrons. 8, 8. How many? 16. 16 and 8, 24. Okay, but sulfur is not octet over here. We need to make octet the sulfur. Why we didn't fulfill the octet of boron? Because boron was an exception. Over here you can see that boron was an exception because boron has only 3 electrons in its outermost shell. It doesn't obey octet, so that's why we cannot bring these 2 electrons as a double bond over here. And fluorine always has a single bond. That's also a reason. So over here we can do one thing. We can bring one of these pairs and make a double bond. For example, I am bringing this over here. We cancel this one and we write it like this. Okay, so we cancel this one And now let me calculate the number of electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. We have 24. Let's have a look. Are they octet or not? Our here, oxygen has 8 electrons around it. This means that it's octet. This one is also octet, and this oxygen is also octet. Before, the sulfur was not getting to octet state, but right now it has also 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So now sulfur is also octet, which means that this is the correct form or the correct structure for sulfur trioxide. Okay? Let's go for the next one, carbon dioxide. Again, I am writing carbon in the center and oxygen on the sides. How many electrons? Now you can see that 4 electrons for the as a valence electron of carbon and 6 electrons for the oxygen. 6 times 2 makes 12 electrons. If we add up 4 and 12, the total number of valence electrons are now 16. Now we have 16 electrons to put up as a dots around or inside this molecule. Okay, let's see. I have told you that according to the first step, we have to put a pair of electrons between each atom. Now we have done it. How many electrons? 4 electrons. How many electrons remaining? 16 minus 4. 12 electrons are remaining. Which one of them is electronegative? Obviously, you know that oxygen is more electronegative. We have studied the electronegativity before. So, this means that we have to complete the octet of oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 8, 8, 16. Now, all electrons are in their places. But, there's a problem. Carbon obeys the octet rule. So, right now carbon doesn't have 4 electrons around his own 4 electrons and the other electrons to fill the octet. So what should we do? I have told you before, in this case we can make one bonding pair into we can change one bonding pair into 2 bonding pairs. For example, we can write this one over here. So we have cancelled this, and we can write this one over here. Now we have cancelled this. Let's count the electrons and let's see if all the elements are octet or not. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Okay. For carbon 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Yes, complete. For this oxygen 1, 2, 3, 4, 5, 6, 7, 8. It's also octet. So this means that right now this is the correct level structure for the carbon dioxide. Okay, students, please don't forget to write the latest structure of sulfate ion, methane, and HCl. Okay, students, see you next time. If you have any question or suggestions, you can write in the comment section below. And please don't forget to subscribe our channel and like our videos. See you next time.